Hey guys, this is Storm. I am back, and this is going to be a look at my cube farm design that I posted on my channel some time ago. And what I wanted to do was take a look at a completely automated version. So this is, this is the semi-automated version I posted on my channel some time ago. And what I want to do is show you guys how to convert something like this, which is a semi-automatic version where you've got to use pistons, buttons, levers, a whole bunch of stuff to harvest the crop like this in this cube farm layout into a completely automated version. So this is basically the same design of this farm, but all the redstone is automated. You don't have to do a thing. All the crops get harvested by themselves automatically, and all the items get stored nicely inside a chest. So I thought I'll show you guys how to make something like this. It will be a bit of a review of the original design. There are a few minor tweaks and changes, and yeah, I'll just get the materials ready and we'll get started. Okie dokie, so here we have the basic outline or structure of the farm already laid out, just to help visualize when we get started here. So this is a 10 by 10 by 10 farm or cube, and the farm is going to be more or less contained within this 10 by 10 by 10 area. And inside this little cube, I've got these two higher support beams basically running through the farm, and this is going to help with creating the different layers where you're going to be planting your melons or pumpkins, and it's also going to help provide support for the redstone, which we'll add a bit later. But the first main difference between the original semi-automatic version and this automatic version is which direction the water will be flowing in the farm. So in this original design, water is pushing items and they all collect down the front of the farm, but in this automatic version I want the items to collect at the rear of the farm. Now this is something you could do whatever way you want, but I'm going to choose to have water pushing items so they collect down this end. So if you don't want to do this kind of stalk design, you could just do the cube by itself. Then you could say that maybe this is the front and this is the rear, or vice versa. Yeah, it doesn't really matter. But in this design, what I'm going to do is have my dispensers at this end of the farm, and these are going to be dispensing water, pushing water and items this direction first. So the first level is basically comprised of a pattern like this. Basically what I'm going to do is I'm going to have a row of, this has to be a non-transparent block here, because I'm going to be sending redstone through this bottom layer at some point. I'm going to have a whole bunch of sticky pistons, another level or layer here of non-transparent blocks, then a whole heap of dirt. And I'm going to be repeating this basic design for 3 levels down. So what will happen is when these pistons are activated, they're going to push up these dirt blocks to this height, which will be the height of where the water is being dispensed, and water will flow this direction. Then I want it to drop down a level here. So on this level I'm going to repeat the same design I did on this level here. So I'm just going to I'll just do one side here just to show you guys what I'm doing. So now I'm going to have the gap on this end because I'm going to want the water to flow down and then run in this this direction towards the back of the farm here. So this is be where you have your pistons, not like that, but like that. There we go. Now I'm having pistons here where the water falls down because when these pistons are activated, the block will be up at this height, but there's still enough space here for the water to flow down in that direction. So just by having these dispensers here, I can squeeze in an extra 2 melons or pumpkins here, and it just increases the efficiency of the farm. So water will flow down this from this top level down to this second level, and then it will flow down this direction. So I'm just going to finish this off, follow the same pattern, and I'll be doing this again down on this bottom level here. There we go, that's the 3 levels now complete. So if we flow how water's going to run through this design, it's going to cruise down here, drop down a level, flow this direction, drop down a level, push items all the way down towards the back of the farm here. And that's the basic principle of this farm, is that items are going to zigzag through the farm down to a common collection point. Now you could stack this design up even further. You could repeat this overall design another 3 levels and keep going up if you wanted to. The only thing you got to think about if you do a design like that, it's going to take longer for the items to all collect at this common central point. So the redstone that we eventually add to this, you'll have to think about extra delays and timers, but it's a very doable design. The whole concept of this is that it's modular, where you can keep stacking them on top of each other. But for this design, I think it works quite well and looks quite good when you just have 3 levels. And this automatic version has just activated. You can see water now is running through the design here. So we should see some items. There you go, you can see some pumpkins flowing down. They'll come down, go into some hoppers, and then they get collected. Just there, we just saw some pumpkins go into that chest then. So that's what we are aiming for with this particular design. So now that we've got these levels in place, the next what we want to do is start adding in some of the supports for where the redstone is going to go. And the easiest way to do that is just outline these borders like this kind of pattern. We'll have to modify this slightly when we start to add the redstone, but for now it's good to just have a pattern like this. We'll repeat this on both sides. So there we go, now we've got this pattern all figured out. Now we have to think about adding in the water. I think at this stage of the build is probably a good time to add in where we have these floating blocks of water. That's going to help hydrate the dirt on each level and increase the growth rate of the melons or pumpkins. So probably the easiest way to do that, I find, is you start at the bottom. And what we're going to do is wherever there's this gap here, we're going to place a block of glass. We're going to create a shape like this. So I need to destroy that temporarily. There we go. I'll replace that block. And that's what we're going to do. At each spot where there's this glowstone, we're going to repeat this pattern. By doing that on each level and this spacing apart, wherever we have planted the melons or pumpkins, the soil is going to be hydrated. And also this kind of pattern, it looks quite good, I think. Particularly at night time, where you see these glowing blocks of water in the sides of this farm. And yeah, I think it looks pretty good. So I'll just do one more down the bottom. And basically we've got to repeat this design. Not there, but there. There we go. Going up the side of the farm here. So there we go. Now we have all the water in place. Just got to double check that all your water should be at the same height level as your dirt blocks. Check. And this bottom level. There we go. So they're all at the same height level here. Just cruise around and check the other side. So that's the basic pattern that we're going with. So that will keep this level here, this row of dirt along this section, all nice and hydrated when we go and plant our melons or pumpkins. Okay, so the next part we're going to work on is sending up power to these dispensers. So this is where we need to start adding in our redstone. Now, there's probably no easy way to do this, or maybe I should say there's no relatively easy way to do this. But the way I do this is I just need to start off with a pattern like so. And it will make sense in a minute, if you can see. So if I put, I only need just some kind of block here, so let's put in that block. So what will happen is, where's this torch? Okay, so the torch is here. That's going to power this block. So if I put a piece of redstone there, and a full block there, in fact I don't even need that block. And I repeat this on this side. So what will happen is when this torch is activated, it will power this, sending a redstone current into this block here, which will activate the dispenser. So this is how we're going to sneak redstone signal up inside this cube farm all the way up to those dispensers. They are quite far away from where the overall redstone logic will be. So this is probably one of the easiest way to send a signal vertically up through this farm. But I'm sure there's other ways to do it, but this is the way I'm going to do it. So you could hear then the dispenser activating. So cool, this design should work, fingers crossed. Now I do need to lower this a little bit further down, because because I need to get this out of the way of visible view when I put in all this groundwork when I want to hide some of this lower level redstone. So let's bring it down one more level here, something like that, and let's just connect up these sections here. So this will be all connected to the one redstone wire, which will be coming from that direction when I want to send a signal all the way up through to these dispensers. Okay, so the next part that I think we should just do is add in where most of the redstone is going to be when I want to power these individual levels of pistons here. And now that we know we've got some redstone coming up through this system, we have to ensure that the wire or the redstone that we add in for the pistons doesn't interfere with the redstone that's going to be going up towards the dispensers, because basically they're going to be opposite each other. So when the pistons are activated, I don't want to be activating the dispenser, and vice versa. So probably the easiest way to do that to start off with is do a pattern like this. So basically the reason why we used glass just here is for this very reason, where I can put redstone going through the glass and it doesn't even look like it knows the glass is there. It does this with any transparent block or slab, and yeah, it's a pretty cool way to send redstone through an area like this without it cutting off the redstone signal there. So we could do something like, well, basically now we all need to do is get redstone going through to these pistons, and probably the easiest way to try and do something like that is just use repeaters. So because we know this block here is going to get power from this torch, I can't just place a regular piece of redstone just here, because it's getting the signal from this block, or from this block rather. So we can avoid that just by using a repeater. So this is the pattern we're going to follow. We'll do this on all three levels, and we'll repeat this on both sides. So there we go. Now we have each of these levels wired up. Now what we do need to do is have all these pistons activate at the same time. And the way we need to do that is have, like we did for these dispensers, we need some way of making this a redstone signal travel vertically up through the farm. But this time around what we'll do is we'll send the signal up from the opposite end of the farm, not to get confused with the dispensers. So like we did here with sending the signal up vertically using a redstone torch, we're going to do the same from this other end. And what we could do is we'll just set it up on a level like this. So the idea is, I do need to add a dispenser, a repeater just here, just so I can activate these pistons. I'm going to use a torch at this level. So for that to work, I need to have, not there, but there. So you can see when this torch is on and it's powering these redstone, this torch is also on. So it's nice that the overall height distance here means we have an odd number, and it means that this row of redstone here is activated when this row is. And same with the level below this. So I'll just add in this next level. So there we go. So that's activated, this one's activated, and this one's activated. So that's what we want. We need to repeat that on this side as well. You can start to see that you do start to run out of space a little bit. So there is a bit of planning required in going into making a build like this, otherwise you'll be pulling your hair out probably trying to figure out how do I place this redstone or this block when you're in such a tight squeeze, particularly in survival mode, which is where I originally made this design, by the way. Okay, so to power up these missing, or whatever these things are called, sticky pistons, yes, those things. Okay, so similar to what we did here where we had to add in a repeater, Here these two pistons aren't activated, so the way we'll do that is we'll just do this, which will add in just some redstone dust and a repeater. So those two are now activated. We'll do the same on this side. So there we go. Now these ones also need to get activated. And for this we'll just add in the repeater. If I can fit, there we go. So all these pistons should now be activated. Let's cruise down, let's check that out. Now there's going to be two at the back here that aren't activated. And that's okay, because what we're going to do is I'm going to extend the redstone from one of these levels around to power these two pistons. So a very simple way to do something like that is let's do this, shall we? So I'm going to want redstone to travel around from this level here. Now because this block is going to get powered by this redstone torch, I do need to add another repeater here to make sure the redstone doesn't get crossed. And there we go. That's a pretty easy way to extend out the redstone from one of these levels and power these two end pistons here. I couldn't just run a normal redstone wire because of this power that's running up through these blocks here. So these are all connected now on one end, and what I need to do now is connect up. The easiest way is to do it like this. So if I send, let's test this out, a redstone signal through to this wire here, it's going to deactivate all these pistons. And of course, when I remove that signal, they're all activated. So that's what we're going for here. Now we also can do the same test on this side, and we can see if we can hear it. I should hear the dispensers activate when I send a redstone signal here. There you go, you could hear that. Take this away. Nothing, good. Okay, so that tells me that we've got all the redstone pretty much where we want it to be. The next fun part is working on the timing. So this is where we want basically two different types of redstone signals in here, one activating the pistons, the other one activating the dispensers, and getting the timing right so they turn on and off when they should to try and maximize the growth potential for the crop here. Okay, so the redstone that we're going to be making, which controls all the timing, is going to be pretty much right underneath where I'm standing now, which is where the stem or stalk area will be. And so it's at the rear of the farm, this is the front, and we're going to be hiding all the redstone down the back here. So let's dive down into here and get ready for that. So first part, what I need to do is have two very clear paths here for where redstone is going to be setting a signal to this back redstone signal, or a set of wires. Let's do something like that. So that's going to be one little connection here where I'm going to send a redstone signal, and I also need to connect up this piece of redstone here. So do I need a block there? I do need a block there. Whoops, not there. There. Let's see what this looks like. So I have a block there, a block there. Yeah, this should work, I think. We'll just wrap it around a little bit. Okay. So here we go. I have two sections here now. I have very two clear paths. I'm going to be sending redstone to either this path or this path. And I need to have controls to be able to do either of those. There we go. So I don't think I need that block, do I? No, I don't. Okay, so there we go. I think now we're all good to go. So there's this one connecting it down to this redstone, and this one's connecting up the front of the redstone here. So the next parts I'm going to start working on are very particular components of redstone, and they're all going to have a particular function or purpose. And for you who may or may not be a little bit experienced with redstone, you may know what I'm building right now. If not, that's fine. I'll introduce you to what I'm making in a second. We could do something like this. Have you guessed what it is yet? No idea? Okay, so I need a comparator here. I need to extend this signal just for a little bit, so I'm going to have a repeater there. So what this is going to be is a T flip-flop. So what that will mean is I'm going to send a signal. This is now activated. If I send another quick signal, it's now deactivated. And it's going to remember what state it's in. And the way that works is, by these redstone torches turning on and off, it's going to allow the item that I have in here to quickly move to this other hopper, and it will stay there when this block is powered. So when this redstone torch is activated, it's not going to move again between the two hoppers. These two hoppers are facing each other, so they're connected. And this is a very simple way to create a T flip-flop. It's basically a switch where you can see the redstone will either turn on or off. So it's on, it's off. So that's the first key part. Okay, this next section of redstone that I'm going to be making, or redstone circuit, is probably not going to make a whole lot of sense while I'm making it, but hopefully I can tie it all together towards the end. And I can already see one problem here. I'm going to need a piece of redstone dust just here. I don't need this one down the end. And the reason for that is I want a redstone torch here to connect up to this redstone. Okay, so what I'm going to be making with, I have this lovely green hardened clay, is going to be pulse limiters. So I don't know if you know what pulse limiters are. This needs to be on a 2-tick delay. If you don't use a lot of redstone or know much about redstone, you may not know what a pulse limiter is. But basically what it does is it's a relatively easy way to transfer or alter a constant redstone signal from the constant redstone signal into a short pulse. So where it will basically turn on and off really quickly. And the reason why I need that is because I only need to send a very short redstone pulse through to either this piece of redstone or this T flip-flop. I don't want to send a very long signal through to those. So that's what this little section here is going to do. So these are 3 pulse limiters, just a simple vertical design. And I need to connect these things together, so I'm going to place 5 blocks this way. And the number of blocks that I use going and joining these together is important. And I'll explain why in a minute. So let's just connect these up first. There we go. Okay. So the next part, I just need to join this piece of redstone dust here, or this signal, to run underneath these pulse limiters. Just need another block there. Okay, so what's going to happen is I'm going to have a torch there. This torch is only going to activate this wire, and this one is going to activate a couple of things. It's going to activate both this wire underneath and the wire in front, this one just here. And basically what I'm going to be doing here is having this output, so from this piece of redstone dust here, which is going to quickly turn on and off, is going to control 2 things. It's going to control dispensers, and it's going to control pistons. So this output here of redstone, which is this set of redstone just here, is controlling pistons, and this one here is controlling the dispensers, so the water flow. So basically what I want is I want the pistons to activate and the dispensers to activate at the same time. Then I want just the dispensers to activate, which will be the output from this redstone torch. So that will stop the water flowing. Because it takes a little while for the water to stop flowing, a little bit later this pulse limiter will activate, and that will activate this T flip-flop and lower the pistons. So if we lower the pistons too early, it's going to make the whole cube farm basically flood full of water because water is still in the system. But with a bit of a delay, hopefully that does not happen. That's what we're going for anyway. Now I'm going to need to have this repeater here on 2 ticks as well, or 1 tick rather. 2 ticks. 3 ticks. Okay, so this is now wired up. The next part is I need to add in the overall clock. Let's pick another block color for that. What should we make that in? How about yellow? Okay, I'm just going to place down the overall layout first, and then we'll place the actual clock design. Okay, so the way we're going to have this clock activated is a whole bunch of hoppers all pointing at each other. So they're going around in this loop fashion here. And what we're going to be doing is detecting when there are items inside each hopper, and then restricting the flow of the items to the next hopper, the adjacent hopper. Now that may not make a whole lot of sense. I did create a video talking about a whole range of different timer designs with hoppers, and basically with hoppers, because with hoppers we now have the ability to create very long pulses and clocks and all sorts of fun stuff with Redstone. What am I doing here? That's right, I need a repeater. Comparator. This is going to be sending a signal to this block, which is sending a signal to this dust, which is sending a signal to that repeater. So basically that's the overall loop pattern that I'm going for. If I just add in a stack, there we go, just a stack of items here. So what happened is, because this has a number of items in it, the strength of this comparator is directly dependent on the number of items inside this hopper, and it was strong enough to send a signal all the way down to this pulse limiter here. So at the moment, what this farm should be doing is happily allowing the crops to grow. So at the moment, that's what should be happening. These items will come around again, and then what will happen is, as the strength of this output of the comparator increases, which is based on the number of items going into this hopper, each of these pulse limiters will activate at different times. So the first one will activate. This one will raise the pistons. It will activate. So this one here is the pistons based off this T flip-flop. It's going to send a signal through to this redstone, activating the dispensers. So now we have water flowing through the system. We have the pistons raising the dirt blocks, breaking away the melons or pumpkins, and as the strength keeps on increasing, the redstone will travel around here to this pulse limiter. That will activate just this redstone here, which is the dispensers, so it will stop the water flowing. Then finally, as the strength gets to the maximum, it will hit this repeater, and that will deactivate or lower the pistons. So that's what we're going for. And that's basically it. So I'm just going to, what am I going to do now? What I think I'll do is, this is the tricky part, because if you get this wrong, you're going to destroy all your redstone and all your wiring. So all of these things need to be hooked up perfectly now. Otherwise, yeah, when I put water in those dispensers, you're going to have water flooding everywhere. So first of all is the timing. You need to get the timing of this clock right, and just by this design and the way we've got these blocks laid out, this design works best. It works most efficient when all of these hoppers are full of items. So I'm going to add another 4 stacks of items in here. So there's now completely 64 stacks of items, and that is a great amount for when items are moving inside to this hopper and sending the signal strength all the way around down to this repeater here. So where is things now? So currently items are moving inside of this hopper, and what I don't want, so right now these pistons should be lowered. So I can trick the pistons to thinking they should be lowered right now just by sending a quick pulse through. There we go. So the pistons are lowered. And what I'm going to do, I'm just going to wait for items to start moving inside of this hopper, and then we'll watch all three of these pulse limiters activate. So now we have items moving into this hopper. So as items fill up these slots, the output of the redstone from this comparator is going to increase in strength. So it's already hit this first repeater. So what that has done is both activated the dispenser and these pistons. So all the pistons are up. Water will be flowing through the system right now. And next what we should see is the redstone signal traveling around and hitting this repeater. That's going to activate this piece of redstone for a short period of time, which is going to turn off the water flow. So we should see this pulse just then. There we go. We just saw that pulse. And the final part, when the signal strength travels all the way around down to here, this is going to send a redstone signal to this bottom wire, which is going to lower the pistons. So we should see that shortly. So there we go. So that sent a pulse, travel along here, and the pistons are now lowered. So right now, if we had our crops planted, they'll be happily growing at this stage. So the final touches, all we really need to do now is start to add in the crops. So what are we going to plant? We're going to plant some pumpkins in this particular design. And it'll be a basic design like this. Needs to repeat on all the levels. This is where we should start to see these blocks become hydrated from the water we placed earlier. So water will flow down here, hit here. There we go. Now what will happen is when these blocks get pushed up by the pistons, they'll be at this height, but water will flow down and destroy the stems here, or the actual stalks, or whatever you call these things, where the melons or pumpkins will be growing. And to stop that or prevent that, probably the easiest way is just to use some glass. So you could use some of the new fancy stained glass that we have. I'm just going to use the regular glass for this particular look. So I'm just going to add a row here of glass. So when these dirt blocks get pushed up to this level, there's no way for the water to escape and destroy all the lovely redstone that we've now put into the system. So I need to repeat that on this level as well. Water will come down here. There we go. And all that's really left to do now is have some hoppers here to collect the items at the end. So probably the easiest way to do that is, first of all, let's have a hopper facing this way. And I'm going to join these two hoppers together. So this is going to move items in this direction. And these pistons will be activated to this height. Water will flow down, so I do need a block there and there. So when water flows down, it's going to be resting here on top of the hoppers and not flooding everywhere else. So next steps really are just to complete the sides with glass. So that is what I'm going to do, is just basically repeat this on all sides. This is mainly for aesthetics, but it's also used to stop the water flow when it hits the ends of each level. So on this level, for example, when the water comes down this way, I don't want it to flood down this direction, so the way you do that is you just have glass running along here. So what I'm going to do is just complete glass on all sides, and then we'll just finish off the finishing touches. there we have it. That's the basic outline of the outside complete. I think it looks okay like that. So if we jump in, the crops are still growing. We could use bone meal to increase the rates. And if you're really nervous about water dispensing out of these at different or incorrect intervals, you could place a block here to ensure that water won't flow down this way and also destroy your redstone. In fact, we might do that anyway. I'll probably use glass though. So we'll just add a line of glass just there. So there's no way now that water, even if it came out and dispensed, it won't run down this direction and destroy your redstone. Worst case scenario is it will come in here and flood all your crops away. So if we follow this path down, water will run this direction, fall down, water will flow in this direction. Yep, that's fine. And items are going to collect in these hoppers just here. Now what you could do is pretty much just add a chest just here if you wanted to. Oh, there we go. So all these pieces are now activated. If there was water buckets inside these dispensers, water will be running out through the system right now, and items will be collecting down into these hoppers. But as I was saying, you could add a chest just here, or what I like to do is have a chest out here somewhere where we could hide it in the stem or the stalk, and that way you can easily access it. But you can be as discreet as you want with how you place these hoppers. You just need to basically connect them all together, and let's just do that now. It's a little squeezy in terms of room. Can I get this last one? There we go. So all these are facing this direction. So items will collect in these hoppers, move items down to where? Just there. I could probably move it one more. There we go. And we could add a chest just there. So I'm just going to finish off doing this stem design here, filling this with just this brown wool. I'll put a ring of brown wool also around the base here just for aesthetics reasons. Then we'll watch this farm in action. See you in a second. Okay, so I've placed the rear of the stem here. I've hidden away the chest. I'm just going to cover up these blocks here, so when the water comes down here, it's not going to flow over the hoppers and then down into the redstone. So now this is all nicely contained here. Need to get out of here before I get trapped. So we already have some pumpkins growing. Let's just climb up out of here. And then, have I added? No, let's add in our water buckets. Let's get that. There's one. There's two. And I've just added a bit of carpet on top here, on top of where the glowstone is and where the redstone dust is. So there's a piece of redstone dust underneath here. So nicely hidden on top view here. Oh, there we go. So we can see the system is now activated. We have both the dispensers activating or shooting out the water. The pistons are activated at the same time. And now we'll see the items flow through this system. And now they're down onto this second layer here, so if there are items broken here away from, if there were pumpkins growing on this level, they would have also been broken and flowing through the system. Now we can see the items coming through and they will fall down onto the hopper, move items into this chest here. So we've already got 13 pumpkins collected already just from this one harvest. Here just then the dispensers turned off. And the last few items just fell down into the hoppers. So we can see that there's enough time, even those pumpkins that just fell into the hopper just then would have been the ones that were growing around this level here. So even if there's crops all the way towards the end here, there's enough time with the timing that we have from the redstone for all those items to fall down into the hoppers. Then you could see then the water drains away before we lower the pistons. And just like that, we can see that pumpkins are already starting to regrow. So that's it. That's the design. That's the overall look. Hope you guys like the build. Hope you guys like the redstone as well. And even better, I hope you guys could actually understand some of the redstone. So Let me know what you guys thought. Leave a comment, leave a like if you like this kind of video. And yeah, thanks for watching, guys. Till next time. Cheers.